All right, so today we're going to start off by talking about the difference between inductive reasoning and deductive reasoning. So honestly, with you guys, I kind of skipped over inductive reasoning just a little bit because inductive reasoning is something you actually use all the time. So instead of spending a whole day on it, I just want you to write a quick definition up here. Inductive reasoning is the process of reasoning logically from patterns or observations, something like that. Key word here, patterns. So inductive reasoning would be, here's an example, a real basic example. If I give you some numbers, 2, 4, 6, 8, could you tell me what the next number is? You'd probably say 10. You just use inductive reasoning. You're looking at the patterns to form a conclusion. So deductive reasoning is kind of the opposite. Deductive reasoning, which we're going to focus on a lot in geometry, is the process of reasoning logically from given statements or facts to a conclusion. So I don't know if anybody has told you anything about geometry and what you're about to learn, but there are proofs involved. And if anybody has told you anything about proofs, they probably say, oh, the proofs are so scary. They're really not. Proofs are just literally proving that a statement is true based on facts. So proving that this is true all the time. These are the facts that have been presented, so this is true, okay? So deductive reasoning, facts. Whoops, I meant to highlight. Inductive reasoning, patterns. That's really all you need to know between the two. So deductive reasoning has two laws of logic that we're going to focus on today. The first one is the law of detachment. So the law of detachment says, if the hypothesis of a true conditional is true, then the conclusion is true. I feel like this is pretty self-explanatory if we kind of take a look at it. It says if P, then Q is true, and you know P is true, then Q is true. I feel like this is like the common sense law. We're going to read this kind of with some real world examples, and I think you guys will catch on pretty quickly. It says, using the law of detachment, what can you conclude from the given true statements? So A, if a student gets an A on a final exam, then the student will pass the course. So this is the conditional. Then it says, Michael got an A on his geometry final. So what can you conclude? Michael will pass the course. Obviously, because that's what the statement says. The conditional, the hypothesis was if someone gets an A on the final exam. Well, Michael got an A on his final exam. So therefore, the conclusion has to be true. He's going to pass the course. That's law of detachment. B, if a ray divides an angle into two congruent angles, then the ray is an angle bisector. So there's your if-then statement. If a ray divides an angle into two congruent angles, then it's a bisector. Ray RS divides angle ARB so that angle ARS is congruent to angle SRB. So ask yourself, that statement right here, whoops, does it match what this is saying? It's saying the ray divides the angle, so that's two congruent angles. Yes, okay? So we can conclude that ray RS is an angle bisector. Because it fits that conditional. So the conclusion must be true. Okay, part C. I want you to try this. Pause it, read it, think about it, see if you can come up with a conclusion. If two angles are adjacent, they share a common vertex. 1 and 2 share a common vertex. This probably tricked some of you guys. Does this statement match the hypothesis? This is saying 1 and 2 share a vertex. The hypothesis is that they're adjacent. These two do not match. This actually matches the conclusion, so we cannot form any conclusion. No conclusion. Here's why. I want you to think about two angles. Angle 1 and angle 2. It just says they share a common vertex. Remember, the vertex is like the point. So what if I have this as angle 1 and this is angle 2? They do share a common vertex, but does that mean they're adjacent? No, remember, adjacent meant they were right next to each other. These are actually vertical. So you could come up with like a counter example for this to prove it false. And you could say like vertical angles. That one's tricky. Okay, I want you to try the next one though. Remember, you want the detached statement to fit your hypothesis. If the hypothesis is true, then the conclusion must be true. If a figure is a square, then the figure is a rectangle. The figure is a rectangle. Remember, we want this to match the hypothesis. Does it match the hypothesis? No. Again, just like the last one, it matched the conclusion. So this one's also no conclusion. You could come up with a counterexample for this one too. Whoops. It says the figure is a rectangle. That doesn't mean it's a square. Just because a figure is a rectangle doesn't mean it's a square. So there's my counterexample. I just drew a rectangle, it's not a square. Kind of goes back to that thing you probably learned way back when. A square is always a rectangle, but a rectangle is not always a square. E, if there is lightning, then it is not safe to be out in the open. There is lightning. Does the detached statement match the hypothesis? Yes, it does. So if there's lightning, it's not safe to be out in the open. There has been lightning, therefore it is not safe to be out in the open. That's your conclusion. Okay. So if the hypothesis is true, then the conclusion is true. That's the takeaway. If you want to write it down, write it down. Here's the main takeaway. If the hypothesis is true, the conclusion is true. All right, next law. This is the law of syllogism. The law of syllogism allows you to state a conclusion from two true conditional statements. So this one is going to have two if-then statements, unlike the last one. So when the conclusion of one statement is the hypothesis of the other statement, then you have a true law of syllogism. So let me explain this. Let's read this first. If P then Q is true, and then Q then R is true, then P then R is true. I like to call this the chain of events. This is the easiest way to explain it. Chain of events. So let's just read an example really quick. Using the law of syllogism, what can you conclude from the given information? If a figure is a square, then the figure is a rectangle. If a figure is a rectangle, then it has 4 sides. That's what all of this P, then Q, then Q, then R means. If these two match, if this conditional is the same as this hypothesis, that chain of events is true. So if P, then R becomes true. So here's how you would write the conclusion for this. If a figure is a square, then that means it's a rectangle. And if it's a rectangle, then it has 4 sides. Do you guys see how I kind of cut out the middle pieces that matched? As long as the middle pieces do match, like the conclusion from the first matches the hypothesis of the second, then that whole chain of events is true, to where if a figure is a square, then it has 4 sides. You can kind of cut to the chase. It's a chain of events. So let's try it again. If you do gymnastics, then you are flexible. So here's the conclusion of that statement. If you do ballet, then you are flexible. Do you guys notice how those two middle pieces, I call them, do not match? This is not how the law of syllogism works, okay? This is not really a chain of events. Both statements are related to being flexible. However, doing gymnastics and doing ballet are not directly related, okay? So this one would be no conclusion. It's not a true chain of events. All right, let's do the next one. If a whole number ends in 0, then it is divisible by 10. If a whole number is divisible by 10, notice it repeats itself, then it is divisible by 5. So this is a true law of syllogism example. So we could form a conclusion from this. It's that chain of events. If it ends in 0, it's divisible by 10, and if it's divisible by 10, it has to be divisible by 5. So our conclusion would be, you kind of cut the middle out. If a whole number ends in 0, then it is divisible by 5, which is true. Okay, and I want you guys to try D. See if you can form a conclusion or not. If it does not fit that chain of events, like law of syllogism, you put no conclusion. If it does fit law of syllogism, where it is that chain of events, then you can form a conclusion. Basically, start with the if, end with the very last statement. So this one does work. It says, if it is Saturday, then you walk to work. And if you walk to work, then you wear sneakers. Therefore, if it is Saturday, then you know you're going to wear sneakers. So, some of you might find logic very simple, okay? Some of you guys might be confused. I get that this doesn't feel like math. It just takes a lot of practice, and that's what we're going to do the next few days. We're going to practice these two laws. So if you need any help, remember there are resources out there to help you. Reach out. Don't be afraid to admit you need help. And I hope you guys have a